The ancient city of Athens, the heart of Greek culture and learning. The streets are filled with scholars, philosophers, and scientists, all eager to unlock the mysteries of the universe. The Greeks had a profound fascination with the cosmos, and astronomy was a crucial part of their quest for knowledge. Astronomy wasn't just a pastime for the Greeks, it was a window into the divine. They believed the heavens were the realm of the gods, and by studying the stars, they could understand the will of these powerful beings. Temples and observatories dotted the landscape, where dedicated astronomers watched the night sky, searching for patterns and meanings. The Greeks didn't start their astronomical journey from scratch. They built upon the rich knowledge passed down from earlier civilizations like the Babylonians. The Babylonians were meticulous record keepers, and their star catalogues and mathematical techniques provided a solid foundation for Greek astronomers. The Greeks admired the Babylonians' systematic approach to astronomy and sought to enhance it with their own observations and theories. One of the most revolutionary figures in Greek astronomy was Aristarchus of Samos. Imagine being Aristarchus in the 3rd century BCE, looking up at the night sky and daring to challenge the widely accepted geocentric model, which placed the Earth at the center of the universe. Aristarchus proposed a bold idea: the Sun, not the Earth, was the center of the universe, and the Earth orbited around it. This heliocentric model was revolutionary and ahead of its time. While it didn't gain immediate acceptance, it laid the groundwork for future astronomers like Copernicus to revisit and refine the concept. Another towering figure in Greek astronomy was Eratosthenes. As the chief librarian of Alexandria, Eratosthenes had access to wealth of knowledge. In the 3rd century BCE, he embarked on a scientific quest to measure the Earth's circumference. Using the angles of shadows cast by the sun in two different locations, Syene and Alexandria, and knowing the distance between them, Eratosthenes employed simple geometry to make his calculations. His estimate was remarkably close to the actual circumference of the Earth, showcasing his brilliance and the power of observation combined with mathematics. But Aristarchus and Eratosthenes weren't the only Greek astronomers who made significant contributions. Hipparchus, often hailed as the father of astronomy, created one of the earliest comprehensive star catalogues and discovered the precession of the equinoxes, a slow wobble in the Earth's axis. Ptolemy, another influential figure, compiled his astronomical knowledge in the Almagest, which became a cornerstone for future generations of astronomers. His geocentric model, placing the Earth at the center of the universe, dominated astronomical thought for centuries. Greek astronomers didn't just observe the stars. They sought to understand the underlying principles governing celestial movements. They developed sophisticated mathematical models to predict the positions of planets and timing of eclipses. Their work was a blend of observation, theory, and mathematics, reflecting their holistic approach to science. The contribution of Greek astronomers had a lasting impact on the world. Their work was preserved and expanded upon during the Islamic Golden Age as scholars translated Greek texts into Arabic and built upon their findings. This knowledge eventually reached Europe, sparking the Renaissance and leading to groundbreaking discoveries by figures like Copernicus, Galileo, and Kepler. Samos, a small island in the Aegean Sea, around the 3rd century BCE. Here lived Aristarchus of Samos, a brilliant mind with a curiosity about the cosmos that knew no bounds. Aristarchus was a Greek mathematician and astronomer who would go on to propose one of the most revolutionary ideas in the history of astronomy. Growing up in Samos, Aristarchus was likely influenced by the rich intellectual environment of the ancient Greece. This era was a time of philosophical exploration and scientific inquiry, with scholars seeking to understand the universe and humanity's place within it. Aristarchus studied under Strato of Lampsacus, a renowned philosopher, which undoubtedly nurtured his love for learning and critical thinking. Aristarchus' most famous contribution to astronomy was his proposal of the heliocentric model, the idea that the Sun, not the Earth, was at the center of the universe. According to this model, the Earth and other planets orbited the Sun. Today, this might seem like common knowledge, but in Aristarchus' time, it was a radical departure from the prevailing view. Most people at the time adhered to the geocentric model, which placed the Earth at the center of the universe. This idea was deeply rooted in both observation and philosophy. Observationally, the Sun, Moon, and the stars seemed to move around the Earth, making it appear as though the Earth was stationary at the center. Philosophically, many believed that humans were the focal point of creation and thus the Earth must be the center of everything. Aristarchus' heliocentric model was a bold challenge to this worldview. He reasoned that the apparent motion of the Sun around the Earth could be better explained by Earth's rotation on its axis and its orbit around the Sun. He also proposed that the stars were distant suns, suggesting the universe was much larger than previously thought. Despite the brilliance of his ideas, Aristarchus' heliocentric model didn't gain widespread acceptance in his own time. It was too radical, too different from the entrenched geocentric beliefs. People were not ready to shift their perspective so dramatically. The idea of moving Earth was hard to grasp, and there was no immediate observational evidence strong enough to sway the consensus. However, Aristarchus' work was not lost to history. It laid the groundwork for future astronomers who would revisit and expand upon his ideas. Copernicus, for instance, cited Aristarchus as an inspiration when he proposed his own heliocentric theory in the 16th century. Copernicus' work eventually led to a paradigm shift in astronomy, known as the Copernican Revolution, transforming our understanding of the cosmos. Aristarchus' influence extended beyond just the concept of heliocentrism. His methods of reasoning and his willingness to challenge established beliefs inspired other great thinkers. Johannes Kepler and Galileo Galilei built on heliocentric model, providing the necessary observations and mathematical support that Aristarchus lacked. Kepler's laws of planetary motion and Galileo's telescopic observations of celestial bodies provided compelling evidence that the Earth indeed orbits the Sun. In addition to his work on heliocentrism, Aristarchus also made significant contributions to understanding the sizes and distances of the Sun and Moon relative to the Earth. He used geometric methods to estimate the relative sizes of these celestial bodies and their distances from the Earth. Although his estimates weren't accurate by today's standards, they were a remarkable attempt at quantifying the cosmos with the tools available at the time. It is the 3rd century BCE, and the Library of Alexandria stands as a beacon of knowledge, attracting scholars from all over the world. Among them is Eratosthenes, a man whose curiosity and intellect would lead him to make one of the most remarkable calculations in history. Born around 276 BCE in Cyrene, modern-day Libya, Eratosthenes was a polymath, skilled in various fields such as mathematics, astronomy, geography, and poetry. His thirst for knowledge led him to Athens, where he studied philosophy and science, and later to Alexandria, where he was appointed the chief librarian of the Great Library. This prestigious position gave Eratosthenes access to a vast array of texts and resources, fueling his passion for learning and discovery. One of Eratosthenes' most famous achievements was his calculation of Earth's circumference. The story of how he accomplished this is both simple and ingenious. Eratosthenes has heard that in the city of Syene, modern-day Aswan in Egypt, located directly south of Alexandria, the sun was directly overhead at noon on the summer solstice. This meant that vertical objects cast no shadows, and the reflection of the sun could be seen in the water of the deep wells. In Alexandria, however, the vertical objects did cast shadows at the same time, indicating that the sun was at an angle. Eratosthenes realized that if he could measure this angle, he could use it to calculate the Earth's circumference, and here is how he did it. On the summer solstice, Eratosthenes measured the angle of the shadow cast by a vertical stick in Alexandria. He found the angle to be approximately 7.2 degrees, which is about 1/50th of a full circle. Eratosthenes knew the approximate distance between Syene and Alexandria, which was about 800 kilometers. This distance had been measured by surveyors using the travel time of camel caravans. Using the angle and the distance, Eratosthenes set up a simple proportion. If 7.2 degrees corresponds to 800 kilometers, then 360 degrees, the full circumference of the Earth, would correspond to 40,000 kilometers. Eratosthenes' calculation was remarkably close to actual circumference of the Earth, which is about 40,075 kilometers. Considering the limited tools and knowledge of his time, this was an extraordinary achievement, showcasing his brilliance and the power of observation combined with geometry. But Eratosthenes' contribution didn't stop there. He made significant advancements in geography by devising a system of latitude and longitude to map the known world. providing a framework that would be used for centuries. His work in geography earned him the title Father of Geography. Eratosthenes also invented the concept of leap year. He noticed that the solar year didn't consist exactly of 365 days, but was approximately 365.25 days. To account for the extra quarter day, he proposed adding an extra day to calendar every 4 years. This simple yet effective adjustment helped to keep the calendar in sync with the seasons. Beyond these practical achievements, Eratosthenes was a prolific writer and thinker. He wrote books on a wide range of subjects, from philosophy to literary criticism. Unfortunately, most of his works have been lost to history, but references to them by later scholars attest to his intellectual versatility and influence. Eratosthenes' approach to learning and discovery was holistic, integrating observations, mathematics, and logic to answer some of the most profound questions of his time. His calculation on the Earth's circumference wasn't just a mathematical feat, it was a testament to the idea that through careful observation and reasoning, humans could understand the natural world with astonishing accuracy. One of the standout figures in Greek astronomy is Hipparchus of Nicaea. Born around 190 BCE, Hipparchus is often referred to as the father of astronomy. His meticulous observations and mathematical prowess laid the groundwork for many future discoveries. Hipparchus created one of the earliest comprehensive star catalogues, which listed the positions of over 850 stars. He meticulously measured the positions and brightness of these stars, providing a reference point for future astronomers. He made a groundbreaking discovery known as the precession of the equinoxes. This is the slow wobble of the Earth's axis, which causes the positions of the equinoxes to shift over time. By comparing his observations with those of earlier astronomers, Hipparchus realized that the equinoxes had moved, and he accurately estimated the rate of this precession. This discovery was monumental, showing the dynamic nature of the heavens. Hipparchus's work built upon the foundations laid by earlier astronomers like Aristarchus. While Aristarchus proposed the heliocentric model, Hipparchus focused on refining the geocentric model, where the Earth remained at the center. He developed sophisticated mathematical models to predict the movements of the Sun, Moon, and the planets, making significant advancements in accuracy of these predictions. Let's move forward a few centuries to meet Claudius Ptolemy, another towering figure in Greek astronomy. Ptolemy lived in Alexandria during the 2nd century CE and is best known for his work, the Almagest. This comprehensive catalogue compiled much of astronomical knowledge of the time and became the authoritative reference for astronomers for over 1,000 years. Ptolemy's contributions were immense. He expanded upon Hipparchus's work, refining the geocentric model with a series of complex mathematical systems. Ptolemy introduced the concept of epicycles, small circular orbits that the planets followed while also moving along larger circular paths around the Earth. This model, known as the Ptolemaic system, explained the retrograde motion of planets, where they appeared to move backward in the sky. While the Ptolemaic system was later replaced by the heliocentric model proposed by Copernicus, it was an incredibly effective tool for predicting celestial movement. Ptolemy's work demonstrated the Greeks' ability to create intricate models to explain their observations, even if the underlying assumptions, like Earth being at the center, were incorrect. Ptolemy also contributed to other fields, such as geography. His work Geographia was a comprehensive compilation of world's knowledge, including maps and coordinates, further highlighting his intellectual versatility. These great Greek astronomers build upon the observation and theories of their predecessors, enhancing our understanding of the universe. While Aristarchus' heliocentric model was revolutionary, it wasn't widely accepted in their time. Hipparchus and Ptolemy instead focused on refining the geocentric model, which aligned the prevailing views of the heavens. Let's meet two more remarkable thinkers, Thales of Miletus and Anaximander. These early philosophers didn't just ponder the big questions, they tried to answer them with observations and reasoning, laying the groundwork for science and astronomy. Thales of Miletus is often hailed as the first Greek astronomer. Born around 624 BCE in a bustling city of Miletus, Thales had a curious mind that sought to understand the world in new ways. He is famously known for predicting a solar eclipse. Imagine the awe and wonder he inspired when, without modern technology, he forecasted that the sun would be obscured and casting a shadow over the land. This event was a turning point, showing that the movements of the celestial bodies could be understood and predicted. Thales also had some intriguing ideas about the Earth. He believed that the Earth floated on water like a log in the pond. While this might sound strange for us today, it was a significant step towards thinking about the Earth's place in the universe. Thales' ideas was based on observation that water was essential for life and seemed to be everywhere, from seas to rivers to rain. By imagining the Earth floating on water, he was trying to explain natural phenomena in a tangible way, moving away from mythological explanations. Now, let's talk about Anaximander, a student of Thales who took his teacher's ideas even further. Anaximander was born around 610 BCE, also in Miletus, and he was a true pioneer in his own right. He proposed that the Earth was not floating on water, but was a cylinder suspended in space. This was a radical idea because it suggested that Earth wasn't resting on anything, a concept that took a big leap away from the common beliefs of the time. Anaximander didn't stop there. He introduced the idea of the Milky Way as a collection of stars. Imagine looking up at the night sky and seeing that faint, cloudy band of light stretching across the heavens. Anaximander suggested that this glow came from countless stars clustered together, their combined light forming the Milky Way. This insight showed his deep observational skills and his ability to think beyond the visible to understand the cosmos. Both Thales and Anaximander were not just theorists, they were practical observers. They used what they saw to formulate ideas about the natural world. Thales' prediction on the solar eclipse, for example, wasn't just a lucky guess. It was based on his understanding of the cycles of the sun and the moon. Anaximanders' concept of the Earth as a cylinder and his thoughts on the Milky Way were rooted in his careful observations of the sky. Their contributions laid the foundations for future astronomers and philosophers. They were among the first to seek natural explanations for the world around them, moving away from the mythological and supernatural interpretations. This approach opened the door for a more systematic study of the universe, which later Greek thinkers like Pythagoras, Plato, and Aristotle would continue to develop. In essence, Thales and Anaximander were early explorers of the cosmos, using their keen observations and innovative thinking to ask big questions and seek answers in the natural world. Their legacy lives on in the spirit of curiosity and inquiry that drives science and astronomy today. These early stargazers remind us that the journey to understand the universe began with simple yet profound questions about the world around us. The work of Greek astronomers didn't just vanish with time. Instead, it was carefully preserved, studied, and expanded upon by later civilizations. One of the most significant periods for the preservation and transmission of Greek astronomical ideas was the Islamic Golden Age, spanning roughly from the 8th to 14th century. During this time, the Islamic world became the torchbearer for scientific knowledge. In Baghdad's House of Wisdom, scholars translated Greek texts into Arabic, making them accessible to a broader audience. The works of Ptolemy, for example, were translated and studied in detail. Islamic astronomers like Al-Khwarizmi and Al-Battani not only preserved these texts but also built upon them, refining and expanding the knowledge they contained. Al-Battani, often called the Ptolemy of Islam, made significant improvements to Ptolemaic astronomy, including more accurate measurements of the length of the solar year and movement of the planets. The meticulous star catalogues of Hipparchus and the mathematical models of Ptolemy served as essential references for Islamic astronomers, who in turn made their contributions to the field. This period of scientific flourishing ensured that Greek astronomical knowledge was not lost but rather enriched and passed on to the future generations. As the knowledge of Islamic world began to spread into Europe, particularly during the Renaissance, these ancient Greek ideas found new life. European scholars eagerly translated Arabic texts into Latin, rediscovering the astronomical works of the Greeks through the lens of the Islamic scholarship. This intellectual revival set the stage for one of the most transformative periods in history of science. Enter Nicolaus Copernicus, a Renaissance mathematician and astronomer who would change the course of astronomy forever. Copernicus was deeply influenced by the works of ancient Greeks and Islamic astronomers. He studied Ptolemy's geocentric model but was also aware of Aristarchus' heliocentric hypothesis. Copernicus dared to revisit and expand upon Aristarchus' idea that the sun, not the earth, was at the center of the universe, and Copernicus' heliocentric model had a profound impact on the scientific revolution. The Greeks were visionaries. transforming the way humanity perceived the cosmos through their meticulous observations, bold hypotheses, and ingenious mathematical models. The work of Greek astronomers like Aristarchus, Eratosthenes, Hipparchus, and Ptolemy laid the foundation that has endured through the ages. Aristarchus' daring heliocentric model challenged the geocentric worldview, sowing the seeds for future revolutions in astronomical thought. Eratosthenes' accurate calculations of the Earth's circumference demonstrated the power of observation and geometry, providing a model of scientific inquiry that continues to inspire. Hipparchus' star catalogue and discovery of the precession of the equinoxes showcased the Greeks' commitment to precision and their ability to detect subtle changes in the heavens. Ptolemy's comprehensive catalogue, the Almagest, compiled and refined centuries of astronomical knowledge, becoming a cornerstone for scholars across cultures and eras. Greek astronomy didn't just stay confined to the Mediterranean. It traveled far and wide, influencing subsequent civilizations and shaping the course of scientific progress. Thank you for watching episode 2 of the series. Hit the like button and subscribe to support the growth of our channel. Keep looking up.